Hi, if you think that the gradient descent is inside the backpropagation and that neural network consists forward pass, backpropagation, and inside backpropagation there's a gradient descent, you're completely incorrect. So today I'm going to dive into it and explain explicitly why is it so and what should we know about it and what is the correct version of it. So we will dive into my Google Doc document, my Google Docs document, yeah. And if you will be willing to get this document as well, I will put into the description. So let's dive into it. So backpropagation and gradient descent. And before we will dive into it, I want to show you this playlist. This video will be in this playlist, and this playlist is entirely about the neural networks, and neural networks as a mathematical concept from scratch. So if you are willing to know about the neural networks from scratch to the prophy, where we will go later, you need to watch this playlist. So let's dive. Backpropagation and gradient descent are tightly intertwined and go along together in the context of neural networks. This is extremely important. Gradient descent and backpropagation cannot exist without each other, okay? So it cannot exist without each other, otherwise the neural network won't learn anything. And this is absolutely truth, okay? So now we will check what is the gradient and what is the definition of the gradient. So the gradient is a mathematical concept that refers to a vector that contains all the partial derivatives of a function with respect to each of its variables. What it basically means is that we have some vector, and you can think about the vector as the array, if you are familiar with the Python, and this array consists a lot of numbers, and these numbers, each of these numbers represent the partial derivative of some function, but in the context of neural network of a loss or cost function, okay? So there are partial derivatives of the loss or cost function inside this gradient, okay? Now inside this array you can think about it this way. And all these gradients are calculated with respect to the loss, so it means the chain rule is already applied inside the gradient, okay? Now, and the video about the chain rule is also inside the this playlist. I've explained it with the Desmos and visualization. So this is extremely important to understand. Then we will dive into the backpropagation, and this is an algorithm for efficiently computing the gradient. So we've explored what is the gradient right now already. So for efficiently computing the gradient, so what is the backpropagation? This is the efficient algorithm for computing the gradient, and this is it. This is what is the backpropagation. You don't need think about it beyond this is what it is. There is no something else in the backpropagation. Yeah, of course, computing the gradient of the loss function with respect to the parameters of the neural network, and this is also important. In other words, gradient with respect to your neural network's loss function and its parameters is an outcome of a backpropagation algorithm. So basically, what is the backpropagation? I mean, what is the gradient? Is basically, in the context of neural network, of course, is an outcome of backpropagation algorithm. Okay, so gradient does not come from anywhere, like from nothing. It comes from exactly backpropagation algorithm, and you need to understand it. Okay, now or in other words, the backpropagation algorithm calculates and outputs the gradient, and this is it. So you may think about it as about the backpropagation as that this is the efficient algorithm that calculates and outputs the gradient, and that's it, nothing else. Okay, and of course with respect to a neural network's loss function and its parameters. And here as a comment, which is not important anymore, but you can read it. So that this gradient is then used in the optimization algorithm. And for example, I put here the gradient descent, but you need to understand that there is not just the gradient descent, but there is also many algorithms which are not the gradient descents. So I put one example is ADAM algorithm, or ADAM. You can check this out, but doesn't need right now, because mostly all the neural networks usually use the gradient descent, okay? But of course, as an optimization technique, ADAM can be applied. And I'm not sure about the Yeah, but this is optimization technique itself. So, anyways, you can forget about this, but you need to understand that except like be like not only the gradient descent exists, there are also many optimization algorithms which you can apply into neural network, but you don't need to dive into it. So firstly, we will dive into what is the gradient descent. So gradient descent is a technique used to optimize differentiable functions, and this is the definition, common definition of the gradient descent. This is not sorry for that. This is not the neural network definition in the context of neural networks, but this is the common definition. This is the technique used to optimize differentiable functions, and that's it. You need to understand that this is the general definition of the gradient descent. Why there is no general definition for the backpropagation? Because backpropagation was created exactly for the neural networks. And talking about the backpropagation, we're talking already in the context of the neural networks. That's why it's important to understand that this definition is talking about the general definition of the gradient descent. But now, in the context of neural networks, gradient descent involves computing the gradient of the loss function with respect to the model's parameters. What I've read right now, I read that in the context of neural networks, when we talk about the gradient descent, it involves computing the gradient of the loss function with respect to the model's parameters. And I want to ask you, what is this? Computing the gradient of the loss function with respect to the model's parameters. This is exactly what we've discussed right now. This is backpropagation. Computing the gradient of the loss function with respect to the model's parameters. Okay? We're not talking right now that gradient descent is only this. We are talking that the gradient descent involves this step, okay? And then I wrote here that, and backpropagation does this step. Because backpropagation, what itself does the computing the gradient of the loss function with respect to the model's parameters, okay? And then it gives the gradient to the gradient descent. So backpropagation, as we talked before, calculates and outputs the gradient, okay? So backpropagation gives the gradient, because it outputs the gradient, to the gradient descent optimization technique. And then gradient descent updates each parameter by subtracting its partial derivative. And partial derivative with respect to the loss function and its parameters, of course. And the question here is, where does the partial derivative comes from? And as we've already discussed, the partial derivative with respect to the loss function and its parameters comes from the gradient, what was outcomed by the backpropagation algorithm. So all these partial derivatives with respect to the loss function are written in the gradient, and I wrote here it is written in the gradient, and multiplying it on the learning rate. This is important. So we do our updating using the partial derivative with respect to the loss function and its parameters, and multiply it by the learning rate. And here's without the stroke with its parameters, because talking about the updating, we are updating the weights and biases separately. Like for example, you have 3 hidden layers, and then you separately update the first, the second, and the third. Okay, separately I mean the different lines of code. Of course, probably there is a way to make it like at the same time. Not sure about it, but usually it works in such a way. And then I wrote, backpropagation is a step within larger gradient descent optimization process. And this is very important to understand, that backpropagation is a step within the larger gradient backpropagation is a step within the larger gradient descent optimization process. It means that backpropagation does not consist gradient descent itself. Itself. Okay, so backpropagation does not consist gradient descent. Gradient descent consists backpropagation, and this is the trap where I was trapped. That I thought that backpropagation is itself like the concept which includes the gradient descent, but this is basically not that like perfectly correct. It's not correct at all, because gradient descent what consists the backpropagation, and I think this is the big gap, because always when we are talking about the neural network contexts, we are thinking that backpropagation is what it does all the training. Like all the YouTubers and all the people say that that backpropagation, we're going to implement backpropagation, but actually they are going to implement backpropagation inside the gradient descent. But when we talk about it, it seems to be that gradient descent is inside the backpropagation, but this is not so. This is why I wrote backpropagation is a step within the larger gradient descent optimization process. And today in this video you're going to understand everything, okay? What is the neural network and how it works, okay? So now, are backpropagation and gradient descent the same thing? I mean, if gradient descent includes the backpropagation, probably is the same things, but no. The answer is no. Gradient descent is an optimization technique to minimize cost loss function, okay? While backpropagation is an algorithm which computes gradient for a neural network. And this is what we've already discussed, obviously. I wanted to clarify it by this question, okay? So, backpropagation is an algorithm which computes gradient. So backpropagation computes gradient. Gradient descent is optimization technique. Okay, this is optimization technique, efficient optimization technique. I mean, optimization already implies that this is going to be efficient. Okay, so neural networks are usually trained by gradient descent, where backpropagation is the gradient part. And I've highlighted it and make it bold because this is it. Neural networks are usually trained by the gradient descent, not by the backpropagation. But it is important to understand that without the backpropagation, we cannot make the training, because there is no gradient to be updated in the weights and biases to make the loss function decreases. Okay, it's important to understand. So now, when we've learned what is the gradient descent and where backpropagation is, we're going to dive into the neural network and how all this works. I'm going to sum everything. So what is a neural network? Neural network is a compositional, of course not compositional, computational model. So neural network is a computational model inspired by the way biological neural networks function in the brain. So here's the important to understand. This definition I like more than others. So there you will find a lot of definitions of the neural networks, and you will find the neural network as the concept, not in the context of the machine learning. You'll find you'll find different definitions. Like, there's tremendous amount of definitions of the neural network, but I want you to learn this, because this is exactly, precisely correct definition and generalized definition of the neural network. And of course, at the end I put in the brackets that in the context or machine learning, this is precisely correct generalized definition. Neural network is a computational model inspired by the way biological neural networks function in the brain. So this is the first part, okay? And this is the most important part, that this is computational model. Neural network is a computational model, okay? And then inspired by the biological neural networks, this is just, water inside this text definition. The main idea is that this is computational model, and the reason why I'm explaining it so explicitly is because I want you to know exactly what is the neural network. And then I said it is a class of machine learning algorithm, which is also not that much important, but this is because it's important to know that neural network is a class of machine learning algorithms, because in machine learning field there are a lot of algorithms, and one of them, the most popular one, is the neural network. There are a lot of them, just believe me. So now the neural network training process itself is a gradient descent, and you need to understand this. So talking about the neural network, networks, you may ask, is the neural network actually just the gradient descent? And this is not the gradient descent. You see, what is the neural network? This is the computational model, okay? What is the gradient descent? It's the training process. Because what is the gradient descent? In the context of neural network, gradient descent is the training of the neural network. But of course, the definition of gradient descent we've discussed already here. So you may just go on the description and check this file out. So again, the neural network training process itself is a gradient descent. and gradient descent is the optimization technique, but neural network is a computational model. And talking about it later, we will see that what are the steps that gradient descent includes itself. So parameter we'll dive a little bit later in the definition and difference between the neural network and gradient descent. So parameter initialization is the first step of gradient descent technique. So first step of the gradient descent in the context of neural networks, it is the parameter initialization. Okay, this is the first step. Then applying the forward pass step is the second step. So forward pass is the second step of the gradient descent technique. And you may ask me, well, wait a bit. You are talking about the gradient descent technique as that it consists itself the first step of an initialization and the forward pass the second step inside itself, which commonly shall not be so, because I thought like the gradient descent is the loss computation and then applying backpropagation and then parameters updating. But no, actually I also thought that way, that it is just the, what is the training, forward pass is not a training, okay? So initialization is not a training, but you need to understand that if it's not even a training, it what makes the training possible. Without the initialization and forward pass step, the training is not possible, and this is the reason why gradient descent includes this step, okay? So this is important to understand. I just clarify it, okay? So first we have parameter initialization. This is the first step. Then we have forward pass. This is the second step. Then loss computation. It represents the third step, okay? So we just calculate the loss. We, for example, we can use MSE, which is mean squared error, and it's going to form the parabola, and on this parabola there's going to be a point of an error, and we're going to optimize this point of an error by the derivative, but taking the negative derivative, because the derivative is the where the function increases, so we need to use the negative derivative where the function decreases, so to minimize the loss. And this is what the loss computation. So this is the third step. Then once we've calculated the loss, we apply gradient, backpropagation, and backpropagation outputs the gradient and calculates the gradient. And the fourth step is to gradient descent up. Wait, what's the fourth step? Oh yeah, the backpropagation is itself the fourth step. Yeah, I've just separated it with the two sentences. Okay, then the parameters updating is the fifth step, and actually there is no the sixth step, but the sixth step actually is repeat overall first, second, third, fourth, fifth steps as a sixth step. What is the sixth step is to repeat all of them. This is actually not actually the step, but this is the step, like, well, obviously. So now overall process is that we have parameter initialization, and this is the this is overall process of the gradient descent technique in the context of the neural network. So we have parameter initialization, then forward pass, then loss computation. Then we have backpropagation, then we have gradient update, which is the parameters updating, and then repeat. So now you are able to understand how neural network works, okay? So usually when we talk about the context in the context of the neural network and about the neural networks, we think that neural network is the forward pass and backward pass. But what is the forward and backward pass? Forward and backward pass are included into the gradient descent, but we are usually think that gradient descent is included into the backpropagation, which is completely incorrect. And now you've understand almost the whole video, but now I want to a bit visualize it, okay? So if we will go into here, we see this image, and this image a bit small. So yeah, additional references. There is the Stack Exchange, which is talking about the difference between the gradient descent and the backpropagation. So check this out, this will be helpful. But about this, I want to switch. Okay, so we have the bigger image. So in this bigger image, I want to show you what is the training process and what is the neural network does inside itself, okay? So what it does inside, like neural network is a model, computational model, but what it does itself, inside itself is this. Okay, so what it does first is parameters initializing. Okay, parameters initializing is the first step. Then the second step is forward pass. Then the third step is computing the loss function. Okay, then the fourth step is backpropagation, and of course backpropagation comes after the computing the loss, because we are computing backpropagation, which is the gradient. So backpropagation computes the gradient, and the gradient computes with respect to the loss function. What's the loss function? It is the just result of the computing the loss function. Yeah, obviously. So computing loss is the third step. Then the fourth step is the backpropagation. Then the fifth step is a bit updating of the parameters, and then we just need to repeat all of that. So is this the sixth step is repeat all of them again, and all of that consists in this black kind of ellipsis, which is the gradient descent. And I hope this video was helpful. Check my profile if you wanna support. Actually, I've been preparing for this for a good like amount of time. But anyways, if you want to support everything, I have in the description, so you can use the Ethereum to support. Also, I can tutor you. You can just write me Telegram or my Gmail. And I think that's it. So have a good days, guys, and I hope I was able to explore what it actually is and you now understand it. Bye bye.